Have you ever wondered what happens to the weight of objects when they are submerged in water? Let's take the example of two buckets of water, one of which contains a floating piece of wood. The two buckets conundrum. The imaginary situation is as follows. On one side of the scale, we put a bucket full of water, and on the other side, a similar bucket, but with a piece of wood floating in it. The question arises, which bucket is heavier? Common misconceptions. Many people assume that the bucket with the floating piece of wood will be heavier because in addition to water, it contains wood. Others assume that a bucket without wood will be heavier because water is heavier than wood. However, both of these assumptions are wrong. The law of floating and the equilibrium of weights. In reality, both buckets have the same weight. Yes, there is less water in the second bucket than in the first because the floating piece of wood displaces a certain volume of water. But according to the law of floating, any floating body displaces with its submerged part as much liquid, by weight, as the body itself weighs. This means that the scales must remain in equilibrium. Experiment with a glass and a weights. Now let's imagine a different situation. A glass of water on a scale and a weight next to it. When the scales are balanced, the weight is dropped into the cup of water. Many people expect the scale cup with the glass to rise, since the weight in the water loses some of its weight, according to Archimedes' law. However, the scale actually remains in balance. Why? Physics of pressure and floating. A weight placed in a beaker displaces some of the water, increasing the pressure on the bottom of the vessel. This additional pressure equals the loss in weight of the cargo. Therefore, the total weight of the beaker remains unchanged and the scale does not lose its equilibrium. These simple experiments illustrate the basic principles of the physics of floating and pressure. They demonstrate how important it is to understand physical laws in order to correctly interpret seemingly simple everyday phenomena.